Hi, it's Mrs. Weefy, and we are starting Unit 5 on chemical bonding. The first part of Unit 5, we're going to be talking about ionic bonds and metallic bonds. So let's get started. Okay, first lesson is on ion formation. But first question is, what is a bond? A bond is an intramolecular force. So this prefix that we have right here, intra, means within. So intramolecular force is a force of attraction between one atom and another atom within a compound. Can be formed by the sharing of electrons or the loss and gain of electrons. The energy stored within the bond is its potential energy that's usually carried about with the valence electrons. Most of the properties of the atoms are dependent on the valence electrons, which we studied in depth in the last unit. Those valence electrons are involved in the formation of the chemical bonds. Now, chemical bonds can be formed in two different ways. The first is the attraction between the positive nucleus of one atom and the negative electrons of another atom. And we can see in the diagram here, you have the positive nucleus of the one atom is attracted to the electron cloud of the other bonding atom, and vice versa. The second way a chemical bond can be formed is between the attraction, and it's always some kind of force of attraction between positive and negative charges, and this one is between the positive and the negative ions. Positive ions are formed by metals. They lose their electrons and they are called cations, of which we talked about in the last couple of chapters. Negative ions are formed by nonmetals. They gain electrons and called anions. In positive ion formation, atoms are losing their electrons to achieve that noble gas configuration, which we know is chemical stability. So let's take a look at sodium. Sodium's electron configuration: 1s2, 2s2, 3p6, 3s1. So its valence electron is in the third energy level, only has one. In order to achieve an octet, a noble gas configuration, it wants to lose that one electron. And so that's what happens. Very easily, I might add. So loses that one electron, and now its configuration is the same as neon. 1s2, 2s2, 2p6. But it's not neon, and to distinguish sodium ion from neon, we're going to put brackets around that electron configuration and the charge outside of brackets to show that this ion achieved that noble gas configuration by losing that one electron. Now, another way to show the positive ion formation is the electron dot notation, and we see that sodium here has one electron in its electron dot notation. Going to lose that one electron, and so we only have the symbol for sodium. We can't actually see the complete octet. So we're going to write the charge after the symbol to show that it actually lost that one electron. Without the charge, then we're inferring that we have a neutral atom. Another way to show this is using subatomic particles. Sodium has 11 protons, has 11 electrons. That gives it a neutral charge, or a zero charge. When it loses that one electron, the number of protons, of course, is going to stay the same, but now it will only have 10 electrons, and add those together, and that gives us the positive one charge. Now, negative ion formation, very similar. These are with those nonmetals that have a very high electronegativity, or a very high ability to gain or attract electrons, formed by gaining the electrons to get that noble gas configuration. So fluorine's electron configuration is 1s2, 2s2, 2p5, a very high tendency to gain an electron since it has 7 valence electrons, and it gained that 1 electron and achieved that noble gas configuration of neon, just like sodium did when it lost its electron. And just like the sodium ion, we're going to put brackets around, but a -1 charge outside of the brackets to show that this ion achieved that noble gas configuration by gaining an electron. We see fluorine's electron dot notation has 7 valence electrons. It's going to gain that 1 electron and complete the octet with 8 electrons. And now we need to put brackets around the entire structure there and the charge outside to show that fluorine gained that 1 electron to give it a -1 charge. And just like we saw with sodium, the subatomic particles, fluorine has 9 protons and 9 electrons for neutral charge and gains that 1 electron. So still having 9 protons, but now with 10 electrons, and add those charges together and we have a -1 charge. So some definitions. An ionic bond is an electrostatic force. Electrostatic force is just force of attraction between those oppositely charged particles together in a compound. And an ionic compound is very simply a compound that contains ionic bonds. Let's take a look at a video or a little animation.
Ionic bonding occurs between 2 atoms when one of the atoms has sufficient strength of attraction to remove an electron from the other atom. A sodium atom has 1 valence electron, with a stable energy level below containing 8 electrons. A chlorine atom has 7 valence electrons. If the atoms collide with sufficient energy, the chlorine atom will remove the electron from the sodium. The sodium atom loses its only valence electron and becomes a positively charged sodium ion. The energy level below now provides sodium with its stable octet. The extra electron completes a stable octet for chlorine, which becomes a negatively charged chloride ion.
Okay, that's it for now. So until next time, this is Mrs. Wethy saying goodbye.